working really good and everything's stable, so it's sort of a little anxious about changing it. But I think at this point in my project, it probably won't be too hard to change.
Well, Mike, you and I are running along parallel tracks, I think, because, and maybe I'll demo this later, but I'm not sure if I can or not. But just doing something. Well, is Mike still there? Yeah. Similar to what you've done, I've been porting my scripted driving controller to ROS2. And the first part of that was getting the TurtleBot simulator to accept what I'm calling canonical ROS2 commands. So to accept command val, a twist message on command val, and to emit an odometry message on /odom. And that's actually working at the moment. So I'm at the point of trying to get my my scripted driving program working. So you're a little ahead of me, but I'm working with the simulator.
Hey Mike, can I ask you to show us that robot run again? I had a glitch in the recording, and so I want to make sure that gets captured.
Mike, you're also muted.
He dropped out momentarily. I thought I saw him come back, but I never seen his camera though.
Okay, I don't. Okay, so here I am, and
Oh, there we go.
Oh yeah, your audio's back.
Yeah, so there he is, and here's controller, and this is the button to say go to the waypoint.
Okay, and Mike, just for completeness. Oh, where is it, Mike?
Your hands are obscuring the robot, Mike.
Oh, it's not going.
There it goes. Whoa.
But my go button's not going. I'll do it manually. Okay, I did it manually.
Okay.
All right. So
tell us what we, Mike. I'm sorry guys for interrupting, but Mike, can you just briefly recap what we just saw?
Well, previous to this, I hit the Y button on my controller, and that was like to execute my Go program. And I tried to repeat it this time, and it didn't work. So I just did my manual. Like I have these. Like like this joystick here, I can control it, left, right, circles and stuff. And I programmed this to go forward, reverse. I don't know if you can see it or not, but forward, reverse, left and right, or counterclockwise and clockwise, just to make sure it's a perfect, both wheels are exactly in sync or or perfectly inverted. So I can do some calibration. And so what you just saw was, since my Go button didn't work, I just pushed the button here and had it go.
Yeah, I understand.
Okay, but
we all saw it before, so
we did.
This is just a typical demo.
You were called to make a repeat demo,
and boop. Okay, so let's see. I guess the other question I had was, and again, I hate to hold up everybody, but I'm going to do it anyway. Could you repeat briefly what you've accomplished with ROS2 this week?
So with ROS2, I was trying to use this as my local router, Wi-Fi router between my notebook, which has my development system, and my robot. And the Wi-Fi signal was relatively weak. And when I turned on my game controller, which is Bluetooth, it just, excuse me, just stopped. It wasn't any good at all. So I'm looking for another travel router. But what I did in ROS this week is I got my encoders decoding and creating a a frame signal, a transform frame, and I was able to show it up on RViz, which is a way to show different, I guess, frames, and it seemed like it was working in rotation and forward, and so I got my encoders hooked up to the ROS, which was good. I'm using a Raspberry Pi Pico, and I'm just using a simple serial interface that I'm just decoding the text message. I was looking into the Pico for micro ROS, and it looked pretty complicated. Using the Arduino IDE. So I decided I'm just going to do a serial interface, and it works good.
Okay. All right.
And then I tried to cap it off this week by doing a automated go to a waypoint. And so I hacked something together, not using the navigation stack, and it doesn't work that good, except if it's a real simple example of going a straight line. So looks like the navigation stack has a lot of power and does magic stuff that I don't know how to do. So that's it.
Okay.
Yeah.
All right. Now we'll consider that the recording is caught up. And Paul, I believe you're the next one on the queue. So you want to go?
Yeah. So last week, very late, I mooted the idea to the group that was left, that remained at 10 o'clock at night, that maybe there would be some interest in a ROS2 series of workshops, specifically implemented as ROS2 in Docker. You don't have to do ROS2 inside of Docker. You can do it natively. And I actually misspoke last week. I said that Windows seemed like a stepchild because you had to install it from source, install ROS from source. That's incorrect. I didn't know that at the time. I've since learned a lot about Windows and have been installed WSL and tried to get Docker running, or had Docker running on top of WSL. WSL, it turns out, and excuse me if you guys already know that, but I didn't know anything about WSL until this week. WSL2 is basically a virtual machine running Ubuntu. So it's really just the same thing as VirtualBox. The only thing that really sets it apart and makes it good is that you can have your Windows, you're not restricted to having a VirtualBox desktop and all your Windows have to live in that desktop. They can live around in your screen. You can have a terminal window that's running a PowerShell in one tab and an Ubuntu shell on the virtual machine in another tab. It's really very nice environment. And you can apparently install, because it's running Ubuntu, you can get ROS2, you can install ROS2 apparently from binary file, like, I don't know if it's apt or just what it is, but so that looks like it would be a real nice way for someone to do ROS2 development in Windows. The reason I'm advocating Docker is that it lets me deliver a proven recipe, which is something you can't do inside of WSL. I did try to do that, and it worked for the CLI commands, but I couldn't get any GUIs to come out of the Docker container and through the WSL virtual machine and out onto the Windows desktop. So that just, I burned so much time on that, it just didn't work. So Getting back to what I want to propose here in this slightly different group is that I could present, and I think there's an initial round of interest, a ROS2 and Docker DPRG workshop, whose goal would be to educate participants and give them the knowledge and experience to implement ROS in this context here. So the context shows a laptop running Windows or Linux. If running Windows, then it would be running a VirtualBox virtual machine with Ubuntu inside of it and ROS2 installed on that. And then a telemetry RPi that's collecting telemetry from a robot microcontroller. And so the idea, I thought this was maybe a useful step. It's a step short of what Mike's talking about, where he's actually having the ROS2, the RPi send drive commands out to the robot microcontroller. But it's more, I think it's maybe broadly useful because it would enable participants to collect telemetry from their robot microcontroller and do things like plot it in charts, in XY plots and velocity plots and heading plots and all kinds of plots to monitor data, debug data from their robot controller in a flexible way. So I thought that, and please feel free to jump in here and contribute comments if you think this is like on track or off track or whatever. And so to that end, I have so far developed about 3.5 workshops, which I thought would be an appropriate way to help participants gain familiarity with ROS2. So probably most all of you have been in a workshop and know that in a workshop you have a workshop leader who maybe explains some conceptual stuff, but then there are exercises, and the workshop leader helps the participants get through the exercises and explain stuff where they don't understand them, and helps debug problems, at least without bringing the workshop to a complete halt. Helps participants bring them to complete the exercises. And so I propose a workshop first starting off with the laptop and RPi configuration. And so RPi has to do with putting the correct version of an OS, of Raspberry Pi OS down that will support a ROS2 Docker. And then workshop 2 would be putting a Docker engine down and building the Docker and learning about how to manage Docker instances, how to add packages to them. And again, the reason for using Docker is because the repeatability of the environment. All you have to do is download from GitHub my repo of Docker files and build it once you've got Docker installed on your Raspberry Pi or your laptop, and you've got an environment that's almost guaranteed to be just the same as what everyone else is running. So it takes a lot of risk of variation out of the equation. And then I'd propose workshop 3 would be on the ROS2 CLI and GUIs. So which there are several tutorials. So I think we'd want to review concepts like DDS and micro ROS and some other things. And there are several tutorials that I'd envision participants doing, which I've listed here, ending up with getting a ROS bag from a running simulation and looking, analyzing it and looking at the plots of where stuff went and what headings were at different times in a run and so forth. And then workshop 4, I think, is probably going to end up being 2 workshops, which is about creating this ROS package for telemetry that I show here in the drawing that would run on the RPi and emit telemetry and record it to a ROS bag where it could be subsequently analyzed. And are you guys seeing this page that I'm sharing?
Yes.
Okay.
It's very tiny, but then again, my eyes are bad. So.
Oh,
Very tiny. It's almost
Very small. Yeah, if you could zoom it out, it'd be better.
okay. Let me
Yeah.
do 2 things. Let me paste the URL into the chat window so you can bring it up on your. I'm sorry, I thought of that, but I forgot to do it. So you can bring it up on your own laptop. Plop that into the chat. All right. So hopefully you can keep up there. And then I think lastly, we'd talk about ROS2 interfacing to robot microcontroller workshops. I'd like to get micro-ROS going. I haven't gotten that far yet, but by the time we get there, I hopefully will. So
I don't understand this concept of telemetry. Seems like, don't you just, I think you have a micro ROS interface between the Pi and the microcontroller, and that's just Microsoft, I guess, topics and etc. Is that what you mean by telemetry?
Yeah, yes. Well, I think there are 2 styles, and either would work. Broadly, by telemetry, I mean debug data, stuff that you're interested in about the robot, like maybe how much effort is being given to each of its motors, and how fast it thinks it's running, and what direction it thinks it's pointing, and what its XY coordinates are, and where it thinks the next waypoint is, and whatever kind of telemetry or debug data you want. The idea is that the telemetry RPi would receive that data, emit it, and store it in a ROS bag, where you could then subsequently on your laptop run analysis tools like there's the console, there's the graphing utility, there's just a ton of really good ROS tools for helping to debug robots. Does that explain what I mean?
So the Raspberry Pi, I'm assuming is the heart of the robot that runs the high level navigation code, et cetera.
I'm not requiring that. That's not really the intent here. It may be, and it's not a constraint that it shouldn't be. So, for example, Mike would probably use his RPi as both the high-level controller and for recording the topics and debug data. But a lot of other DPRG members use things like everything from an Arduino to an ESP32 to an RP2040, you name it. The robot microcontroller that's running the robot control code, the highest level control code that causes it to navigate from one place to another, is running on this controller. So that I thought that it would be useful for the purposes of debugging the code on this microcontroller, rather than trying to just do printfs and or some kind of like proprietary logging solution that you somehow try and analyze, that you could emit that to the telemetry RPi and capture it there. And there are two ways of that you could emit it. One is using micro ROS, where you actually have ROS topic messages going across this arrow. Another is you have your own proprietary protocol here, where maybe you emit 64 bytes, and the first byte is the heading in degrees, and the second byte is the velocity, or there's a float, or you know what I mean. You can have an agent on the telemetry RPi to receive a proprietary telemetry stream and turn it into your own ROS messages that then can get stored in a bag for later analysis. Does that make sense?
Yeah. Hey, Paul, I do have a question though. This sounds a little bit like, you could use a CAN bus. You could just capture the CAN bus messages, and then use these analysis programs. Is there? I would imagine that ROS2 would have something that would be able to translate CAN bus messages, because they're in all the cars and everything. So, do you know anything about that, or?
I do not.
Okay.
I've worked with CAN in a ROS environment, and we did have a third-party package that let you disassemble the CAN messages, and then effectively we put an agent receiving the CAN messages on and publishing them in ROS messages to a topic.
Yeah, that makes sense. That makes sense. Otherwise, you could just have your filter to set to the ones that you want to take in. And then you could be dumping them. If you wanted to, you could be dumping them into a storage file somewhere.
Right, and the bag is what you call the storage file in ROS speak.
Yeah.
Yeah, usually that stuff, I mean, you don't want to tie it necessarily to a physical interface. The kind of stuff you're collecting is really just upper layer protocol sorts of things, and you can throw that to any stream. It could be serial directly on your benchtop, or it could be wireless to something else. You don't really want to necessarily tie it, telemetry data, you don't want to necessarily tie it to a physical interface, right? Because that can change, or you might lose a link, or you still want to get the telemetry data on what happened.
It really would be up to the robot builder to decide where this telemetry RPi should live, whether it should be, if it's on a desktop, then why not use your laptop? And that's certainly viable. I think the idea of putting it on the robot is you've got a more reliable link between the microcontroller, because Wi-Fi can be a bit tenuous at times, particularly like on a Robo Columbus course, where you're out of touch with the Wi-Fi network for a lot of the time. Unless you've got Wi-Fi locally. So
yeah, you definitely want to store it locally, right?
Yeah. And so the storage idea was to bring it into ROS, store it in a bag file, and then debug it.
Yeah. Well, okay. The architecture I'm working on is like I have the Raspberry Pi, which is the high level brains on the robot running ROS, and then I have a couple microcontrollers. One's on the wheels, and it just does the low-level functions like the PID controller to make sure the wheels are running at the actual velocity.
Can I interrupt?
And the encoders.
Here, please, because I want to use my time here wisely. Okay. And I want to try and find out who would like to be in this series of workshops. So if you don't mind, I'd like to.
Okay. All right. I just think it's getting a little too
I
focused
think we're
on
going
it.
down into the weeds into your robot implementation.
Right.
And I want to stay up at the level of a workshop series and what people are interested in and think would be useful, and how we would organize such a series of workshops. And then that, I see that as setting the context for who would be interested in participating in this.
Yeah, I'm definitely interested. One thing that I was playing with a little bit on the weekend was VS Code dev containers that, basically using the Docker extension and pulling down images and running Docker from within VS Code as separate dev containers. Have you ever seen that?
Okay, that was Brad. That's Brad.
Yeah.
And it sounds like you're ready to use this information imminently. Is that correct?
Well, no, I'm just playing. I actually am still working on my original robot, trying to get things moving. So this is another one of those going down a rat hole. I'm interested, but I'm not there yet from a practical point of view. But I did actually get this working and getting RViz to work within VS Code on a different.
Oh, awesome. And was that Brendan that was speaking before about your robot and where you envision running stuff?
Not this session. I did talk about it last time. I am definitely interested in the workshop because I got this Pi 5 and I like to be able to utilize it. I think that's the way of being able to use it.
And I've got your name down. Who was speaking before Brad?
Mike?
Okay, cool. Good. I got you. I got all you guys. Awesome.
Dave Ackley would also be interested.
Who's that?
David?
David
Abbott?
David Ackley.
Ackley. Okay, great. Perfect. Let me just. So, I've got Brendan. I've got Doug Dodgen. I got your email, Doug, and Doug Parody and Carl Ott from last week, and Mike, and Cooper Clem sent me an email. Is there anyone else who I should put down on the list?
Yeah.
Yes, Paul. I'd like to know.
And I'm sorry, I didn't hear your name well.
This is Brad, and I'm definitely interested.
And this is Tom, and I'm interested.
Okay, Tom C. What's your last name, Tom?
Crawford, CRAWFORD.
Okay, so I've got David Ackley, Tom Crawford. Did I miss someone in the middle there?
Brad.
I've already got Brad Garten.
Okay.
Did you get
Karim?
Did I get who?
Kareem?
No, I did not get Kareem. Thank you. Okay, can I ask you guys to do something for me? I'm going to put my email address in the chat, and can you send me an email, and then offline I'll work with the group to define who the initial participants will be, and to set a schedule. Okay, Kareem, anyone else? Okay.
I'm interested. Yes.
Sorry?
Pat Caron as well.
I missed the name, I'm sorry.
Pat Caron.
Oh, Pat.
Yeah, from up in Canada.
Yeah.
I noticed in the chat that Ed, Mark, and Mickey Dean also chatted that they were wanting. I don't know if they're on your list.
I think you can assume
I sent you a private email, Paul.
Thank you.
I am interested.
Okay. So you want us to see?
Okay, there are some. I want to run by so there's fair few number of people. I'm seeing about 10 to 12 names interested. So let me run by and get feedback from you. First of all, on what I envision the workshops would be, and again, open to input on this, and what they wouldn't be. And then second, a proposed structure for them, and get and see what you all think. So again, I talked about ROS2 running in Docker on an RPi and also on Windows or a Linux PC, a VM on Windows. The RPi would need to be running Bookworm or Bullseye of release of Raspberry Pi OS. So you may want a new SD card. Probably 16 gigabytes is sufficient. PC. So we covered Docker container configuration and building containers and managing them, managing packages for containers, how to capture bag files, how to use the analysis tools, how to create and run the ROS2 software packages, create and build ROS2 software packages. So your own packages. How to add instrumentation to your code, how to make custom debug messages, which is really what you want when you've got your microcontroller and you've chosen to use a subsumption stack, and you'd like to record the changes between subsumption states. We would use C++ and Python for coding. What I wouldn't envision covering would be how to build a broadly ROS-based robot. I think that's too big of a scope. So we can talk about, again, open to input on that. Wouldn't cover ROS1. Wouldn't cover ROS2 running natively on an RPi or PC. Though you might want to do that, but you can't use a standard recipe. Docker gives me a standard recipe where everyone can run the same thing. Wouldn't cover simulation with Gazebo, robot algorithms, Git, or development tools generally, or OO concepts and practice in C++ or Python. Though you do end up using those concepts, but there wouldn't be a focus of the workshop series. Does anyone have any questions or thoughts on that is not list for the workshops, what to cover and not?
Question: when you say 16 gig, are you talking about on the PC or Linux system?
Yep.
Okay, thank you.
Yeah, 16 gig. I found that a 16 gig SD card is plenty for an RPi, and I haven't really measured how much a PC uses, but it's going to be. I would think it would be comparable, and that is the size of the image on the RPi that contains the Docker engine, the built Docker container with all of the ROS2 libraries in it. In other words, everything you need. Okay.
Should that be a Raspberry Pi 4 or can it be a 3?
I think based on my experiments with a Raspberry Pi 4 and a Raspberry Pi 02W, I think a 02W is barely man enough for the job. I think it would work for the workshops. It might be slower than you'd like. I think a 3 would probably work reasonably because it's got twice as much memory. And the main problem is that the 02W just runs out of memory, and you got to start swapping to SD card, and it just drops to a crawl when that happens.
Okay.
So, so that brings up the question of what hardware would participants need to bring with them, and so or have available. One would be a laptop capable of display, and that would be where you display your GUIs and terminal windows from the RPi. And it's desirable, I think, in my opinion, that it be capable of running ROS2 in Docker on your laptop. It just frees you from being dependent on the RPi, but I don't see that as being mandatory in any way. And that the minimum level would be a laptop running VNC to an RPi. Okay, RPi with 16 gig.
But wouldn't we be using VS Code on the notebook to program, to control the code inside the Raspberry Pi?
VS Code, I use it as an editor, and you could certainly use it to edit, but it would not be the thing that would launch files, I wouldn't think.
Right, right. Yeah, because it has a remote interface, which is nice. It does SSH in the background.
Right, exactly, yes. And the SSH to the Raspberry Pi is great, and I would envision using it for that. But then you would build the ROS code, you would run the ROS utilities and build ROS code on the Raspberry Pi.
Right, right. Okay.
And also you can do it on your laptop, which I find convenient because the laptop has way more performance, and I can spread my windows around the desk, around my screen as I wish. I suggest, and this is an optional thing, but I suggest, you definitely need an adapter to connect the SD card to a laptop so you can program, so you can save the image onto the SD card for the RPi. I suggest a serial console socket and connectors to the RPi 40-pin header is desirable, not mandatory, but along with a USB serial, 3.3 volt USB serial cable. If your Raspberry Pi won't boot, it lets you get at the console. And I would envision covering how you configure the Raspberry Pi firmware to enable the serial console. And then you also need a mini HDMI or micro HDMI, depending on whether you've got an RPi 0 or an RPi 3 or an RPi 4 adapter, because when you first boot up your Raspberry Pi, all you've got, before you enable the serial console, all you've got is HDMI. So you need to be able to hook that into hook a monitor and keyboard and mouse up to your RPi for the first configuration. So in the case of like a RPi 0, you need a USB hub that has a micro USB connector. Yeah, micro USB. So stuff like that. That's what I envision for hardware required. Any questions or thoughts on that? Okay.
It's pretty straightforward.
Yeah.
Can you give us a somehow a printable version of what you're talking about?
Yes. If so, you've got the link to the page. So if you click on, see, this is a hyperlink. So let me just share out. Okay, I'll go to this is the page that I shared out. And Workshop 1, for example, is a hyperlink. So if you go to that hyperlink, then you've got the content for the laptop and RPi connectivity workshop. So you can look at that. Feel free to browse it, use it in any way that you wish. Go ahead, jump ahead of the workshop series if you want to. It's all for this group.
Cool stuff.
I haven't found in the messages where your link is.
Where my what? My link?
Yes. You were saying there's a link to it?
So
Yeah, it's under his name.
Yeah, it scrolled off the page.
It's at 7 p.m., so it's earlier in the discussion. So way up, you probably have to scroll up to it.
Okay. Yeah, I see it now. Yeah, 8 p.m.
Mhm.
Yep. Okay. Thank you.
I'm sure.
Yeah.
I'm not sure what you guys are talking about. Sorry about that.
No, I was
I
asking.
don't think you could find your link. Nobody found it.
I found it. Thank you.
Let me go through the workshop proposed structure and get feedback from those who are interested in attending. I talked about what a workshop format is like, and this is a new experiment for me. I haven't done this virtually, a virtual workshop. I envision that I could explain some of the concepts, and then we'd work through the exercises together. And if someone trips over something and something doesn't work as expected, then maybe they could share their desktop or share their terminal out, and we could, maybe I'd get them to echo ROS pipe to grep, or whatever seems to be appropriate to help someone through whatever they're stuck on. But haven't done that before in a real workshop, so it's going to be a new experience. I think I envision 4 to 6 weekly sessions of 2 to 3 hours each, so try and be done in 6 weeks, but open to participants' input on that, as to whether they might want bi-weekly or and when we should start. So I'd envision leading the sessions and demonstrating them and helping participants. I'd envision meeting on Google Meetup like we do for RBNV, only at a different time, and desirably recording them. We may have to fall back to something like Zoom if someone who doesn't have the DPRG Meetup code isn't present. So that's a little bit of a got to get a backup plan going there. I'd like to record them. Can't really say that promise that will happen. But I envision that participants would pick a convenient time to meet for the workshops, and we'd manage any variations. So like maybe someone can't make 1 week, and so maybe I do a makeup session with them one-on-one, or maybe we reschedule. Maybe we pick a different day. Just try and be I want to try and be flexible and meet the participants' needs. I would envision using this meeting as I'm using it now, just for a short segment, if there's any coordination needed, but which I'd lead. But really, the workshops would be offline from this meeting. This meeting is it would retain its current function as a DPRG weekly meetup. And
I really like the idea. Sounds great to me.
okay.
Yeah, I'm flexible. So
Okay.
whatever you guys decide as far as timing goes, I wouldn't have a problem with it.
Okay.
During work time.
I sent you, Paul, I sent you an email about my constraints. I have 2 evenings that are already committed. I sent you an email already.
Okay.
Regarding the content, so I've never done ROS before. You've never taught it before. So maybe you got 4 workshops laid out. Maybe we leave that the way it is. And as we go through those 4 workshops, we may decide and discover what we should fill it out with.
Yeah.
Because I don't know what I don't know yet.
Yeah. Right.
You don't know how slow we are either.
Start doing something, even if it's wrong.
Well, so I've intentionally limited the scope to collecting debug data off of some robot and knowing enough to write some code that would emit it on a ROS topic, and from where it can be saved in a bag file using standard ROS tools and analyzed using standard ROS tools. So that's a fairly limited topic. It's much narrower than building a ROS robot where the high-level controller is in ROS. So I would ask participants to stick to the recipe because if you want to like use a different way of doing things, for example, run natively on WSL, by all means, but not as part of the workshop, because I think in a workshop you want to try and keep the thing going, keep it moving. Otherwise, you get bogged down. And here, okay, so now I'm getting to what may be a challenging part, but let me float this out and get comments on it. I propose that sessions should be limited to 4 to 8 participants. I would envision repeating the series if it's successful, but I think if you go much higher than half a dozen, you start to get people getting stuck on this and that, and you spend a lot of time getting people unstuck. Is my limited experience with in-person workshops.
Yeah.
So I'm sorry, someone said something?
Yeah, I've done a lot of workshops as part of my job. So that actually makes sense if if you're doing a lot of technical work where there's a lot of hardware involved and software subsystems. It makes sense to keep it a relatively few number of stations.
Yeah, thanks for that validation. And I want to avoid wasting participants' time. So what I want to suggest is that I'll announce whatever the participants agree on, and whoever is is in the first session, whatever that number is, and those who are in the first session get to pick the time that we would meet for each workshop. And I would announce that, and I'd support anyone joining as an observer, and observers could follow along with the exercises if they want to. They could ask questions, because I think questions from a wider range of people can only help understanding. But I'd only envision pausing the workshop, and then I'd only pause it briefly for problems encountered by participants, not for observers. So observers could follow along, and when we do exercise, run Colcon to build a workspace, maybe an observer hits a problem. I wouldn't want that to stop the workshop. If a participant hits a problem, I would stop the workshop, at least briefly. So I'm proposing a kind of a stratification here, and want to throw this out and get input from you guys, that participants are prioritized, that the workshops are really for them and aimed at bringing them out of the workshop series with enough competence and knowledge to use these tools and to write programs that use ROS 2. And they would get to set the time for meeting times. That'd be the focus of the workshops, not observers. But observers are welcome to attend, to ask questions, to follow along and do the exercises themselves along with the participants. How does that sit with you guys? What do you think of that proposal?
Sounds good to me.
Yeah. Are you going to do it like a kind of a step-by-step format, and are you going to record it?
I'm going to attempt to record it, and yes, I do envision doing it step by step. So, as an example, if we look at the ROS Docker workshop, there's some theoretical content, a cheat sheet for the Docker commands and Terminator commands. There's some Docker concepts. So this is all kind of tutorial content. But then when you get to hands-on, one of your first steps is to install Ubuntu on a system using these instructions. I might ask people to do that in advance of the workshop. But then configure .bash rc for running Docker. And I've got to say, so envision saying, okay, let's everyone do this step. Is everyone done? And then when everyone's done, then let's move on, build okay, let's go on to build it. So let's launch a VirtualBox VM SSH into the RPi. Let's do sudo apt install git. Let's, in the home directory, let's clone Paul's Docker's repo. Has everyone done that? Yep. Oh, no, you haven't done. Okay, let's just hold up. You having a problem? Let's just, so kind of step by step, because there's a lot of steps here, and someone can race ahead. So anyone is welcome to run ahead, but I think workshops, you usually, at least the ones I've been in, you try and make sure that you bring everyone along through all the steps. So any thoughts or comments on that proposal?
Makes sense to me.
I guess, are you going to make it so we can do it by ourselves if we are so, that adventurous, I guess? Or
Yeah, you can absolutely do whatever, you can do it tonight if you want. These, or at least what might help you would be the what I might say about why you want to launch a virtual box VM and why you're installing Git, what we're going to use Git for, so that these are kind of summary steps or summary notes about do this step. So you might find it a little difficult to follow without the accompanying description. So yeah, I will try and get it recorded. Don't know that I'll be 100% successful for all sessions on that.
Okay.
Are you recommending using Discord as our communications channel instead of simple email?
Thank you for bringing that to my attention. I meant to mention that before. So I have had Murray Altheim create a Discord channel, create a DPRG channel on his Discord server, and I don't know why I don't have that in this collection of. Oh, I know why. It's somewhere else. Let me just go to it, discord.com, and open Discord, and then under the personal robotics. So I once we get anyone who's interested in this identified, and I get their emails, I'd envision sending an mail out saying with invitations to join the personal robotics Discord server. And under the I've had Murray create a DPRG channel, and I pinned the first message saying basically that the initial use of this channel is to discuss and coordinate regarding the ROS2 in Docker workshop series. And I've got a link to the workshop description page, and a note that is presented under the auspices of DPRG, and a note about DPRG and its meeting. So I'd envision using this as an interactive sort of offline. Oh, I can't make Wednesday at 7:30, but I can be there by 8. Is that going to be okay? Or I was unable to get VirtualBox to install. Here are my problems, and then we can work stuff offline through that channel. Any thoughts or feedback on that?
I personally am incredibleized with how much work you put into this, Paul. I really appreciate it.
Well, thank you.
was looking for your email to start the process of the Discord, and I can't.
This sounds like a great project here.
Well, thank you. So I haven't had a chance to look at everyone's email, but I will look at everyone's email and get an email out to everybody. Now, let me just go back to let's see. Okay, so if I heard support for the idea that a half a dozen participants is probably what I want to limit it to, and I think there are more people whose names I've got. So the question is, how do I pick that first half dozen? And so I'd like your help with that, and I propose doing it offline through email. And I'll communicate with each of you individually about that. But one thing that would help, one principle I want to propose and get feedback on is, how when you go to a workshop or a course, you forget what you learned quickly if you don't use it. So I would like to prioritize people who will do things on it imminently. So I think Brad and Mike are both already playing with ROS 2. So I think they can use this kind of knowledge immediately. So I would put you guys right in session 1 if that works for you guys.
Well, I sent you a note on that in the email. Actually, I'm just tinkering with it. It's not actually going into my robot right away, so I could be on the observer.
Well, but I think there's a much smaller number of people that are even tinkering with it.
Okay.
And a larger number that want to know what the heck this thing is, and how would I use it, and so let me just say to everyone else, if you will do something with it imminently, then I think you have I'll put you at the head of the list, because I'd like you to be able to. What I'm trying to do here is enable people to make progress, even if they're not going to put it in their robot, to enable people to use it. Because I think once you get the hang of it and you know what it is, then you'll find a use for it. So anyway, if I could ask you to, Doug Parody has the key to recording. So I want to put him in session in series 1. And so I think that leaves me three spots. So if you guys, I'll send everyone an email, but basically it's going to ask you, are you going to use it imminently? Are you going to tinker with it? Help me make the best choice for the group that I can for series 1. And I'm open to staggering, if people, and also give me an idea of when you'd be ready to begin, because I'm ready to begin tomorrow. I've got session 1 through 3 complete. So give me an idea of when you're, I'm open to staggering it, because I'm retired. I can take time off, and we can even do daytime sessions. It doesn't have to be at night. So help me do the right thing, the best thing for the group as a whole, in terms of a constrained session 1 and maybe a follow-up session 2 at, when should it be? Should it be in a month, in 2 months? I know. I'm looking for input here. I think I've used a fair bit of time, and I think I've covered all the content. Are there any questions or comments before I close?
Sideline question. I don't currently have an available RPi 4 that I can dedicate to this. Anybody knows where a good one can be found? They were short supply for a while. I see them on the Amazon, or at least for sale down in Dallas.
I would try DigiKey. I got an R5 from DigiKey. So I'm sure they have R4s. In fact, I remember looking for R4s, just DigiKey, and they sell them at MSRP. You don't have to pay the inflated cost.
Well, I went to Micro Center.
iShop.us also has them.
Yeah, I went to Micro Center in Dallas, and they had them just sitting on the shelf for $45.
Cool.
Yeah, the 4 meg or 4 gig rather.
Yeah, which might not be big enough.
I don't know if I had to guess, at least 20 of them in the case.
Mhm.
I was there a couple days ago.
I didn't see what size they were, but I think 4 gig is real small. Yeah.
Oh, 4 gig is small. They also had 8 gigs, but
I'm using, just for reference, I'm using an 8 gig, and I find it plenty powerful enough. I'd encourage you to go bigger from this perspective, that if you choose not to run a Docker container, a ROS2 container on your PC, then you'll want to run the GUIs like Plot Juggler and others on the RPi, and look at their output through a VNC window. And so, considering that you're running GUIs on the RPi, I would just recommend more memory is better than less. But I have no data to say, how much you need for running the GUIs. I do know that half a meg is not enough. Is not enough, and you got to do a fair bit of swapping. But it does work. I'm sorry. Let me correct that. On the RPi 0, I was able to bring up the GUIs, but when it came to building, it died on the compilation. So when GCC was trying to compile Plot Juggler, it just absolutely died. And I had minus J1, so only one compilation was going on at a time, and it still used more than the available real memory.
Yeah, maybe 4 is good enough. Yeah.
So yeah, 4 is probably fine. I just if you're buying a new one, I would always suggest getting more rather than less, but that's your call. Okay. Any other final comments and questions?
The 8 gig that they have available is probably an adequate one, or need to find something bigger?
I'm sorry, what about the 8 gig, David?
Well, I was asking if the 8 gig you think is adequate, or need to look for something more.
Oh no, 8 gig is fine. I've been using it, and it's been I've been testing these workshops on both the RPi and my laptop, and it's working good.
Okay, thank you.
yeah. Do they even make a Raspberry Pi 4 with more than 8 gig?
Not that I know of.
Yeah, me neither.
Okay.
Don't think on it.
Are we talking about Raspberry 4 or 5?
4.
We were talking about a 4.
Okay.
But I'll be running off. I'm trying to do it on a 5 because I really want the computational. But I think it's pretty trivial to do the 4 or 5.
I think the Docker container just makes the platform so transparent, unless you're dealing with not enough physical memory, things like that. But I was amazed that the exact same container that I built on for the Raspberry Pi 4 built on the Raspberry Pi 0 and ran just the same. I was amazed. Okay, anything else before I leave? Okay, thank you for your interest, gentlemen, and I'll get back to each of you through email. Thank you. Okay, what happened to Doug? Doug was leading this meeting. Doug's got his headphone off.
He turned off the lights.
And
I think I was next.
Go ahead and go, Pat.
If nobody was ahead of me, I'll go.
yeah,
Thank you very much, Paul. That was very informative. Looking forward to hearing your choices.
thank you.
So I have been working on, as many of you are aware of, basically a little motor driver using an Arduino. I was using an Arduino Uno, and I ran into a problem where I'm trying to use a servo output on pulse width modulation 9 and a motor driver on pulse width modulation 10 and 11 because of the design of this board. And I wasn't having very much luck with it, trying to change the pulse width modulation frequency, essentially because they're all on the way the timer arrangement is. The board layout is not very good. So what I've done, basically I'd covered this before, where timer pins D9 and D10 are timer 1, and I can set the pulse width modulation on those ones. And for 11 and D3 and 11, I can also set the pulse width modulation on those guys, but they don't match using the prescaler divider. They don't come out quite the same because of a difference in the timers in the Raspberry Pi, or the, sorry, Arduino Uno. So what I've done is I've switched to Raspberry Pi, or sorry, Arduino Uno R4 Minima. And I'll share my screen again, the whole screen. And I don't know if I can do a window share. So there is basically a plot or from the timing on the Arduino Uno R4 Minima. So that's the latest Arduino that they've come out with.
Mm-hmm.
They have the Uno R4 Minima and the Uno R4 Wi-Fi, I believe it is. So I grabbed the one without Wi-Fi. And what I was able to do on the pins D9, D10, and D11 is basically to get my signal the way I wanted it. So I've got a pulse width modulation on servo pin 9 of 50 hertz, which is, I believe, is what the those require. And right now I'm setting out a 1.47 millisecond pulse. On that same timer on the old Arduino, well, now I'm able to change the timing, and I'm at 25 hertz, and I'm sending out a 50% duty cycle on that pin. And then on pin 11, I'm sending out a 75 hertz pulse width modulation at a 50% duty cycle. So I was able to resolve my issue with timers quite easily on using the Arduino R4. With actually, that was a very minimal amount of code to used for setting that up. So it's quite easy. It uses a pulse width modulation PWM.H library, which is built in, and basically you set the pulse width modulation out mode on those pins, and you initiate the pin with in the setup. So you initiate it with a period. So 20,000 20,000. I don't remember if that's my period. In milliseconds, or in microseconds, I'm sorry. And then the same on the other pin for 40, which gives me 25 hertz. And 1332, which gave me approximately 75 hertz. And then basically, just by issuing the command, so pin 9 gets a pulse width microseconds output command, and then I just map it into the appropriate microseconds depending on the degrees. And then the pin 10 and pin 11, I'm using pulse percent output for those pins. And I've just set it to put out a 50% duty cycles pins. It was actually very easy to do, and it's working quite well. There's a lot of flexibility with pins and timers on the Arduino Uno R4. So, as well, a gain in memory and a gain in speed execution.
Cool.
I thought I would share my findings and let everybody know that if they're looking for some additional flexibility, it could help quite a bit.
Pretty cool. Yeah. So where did you?
What chip is that based on?
Sorry, what was that?
What chip is that based on? Do you know?
That is.
Is it like a Cortex M4 maybe or something?
No, it's
AST.
I think it's an M0, but I'm not sure. Go ahead. Yeah. But it's not ST.
Oh, it isn't.
Yeah. Yeah. Did they give you I'm just under. They give you an overview of it. It's a 32-bit processor. It's 5-volt inputs on the pins.
5-volt tolerant, you mean?
Mm-hmm.
5-volt pins.
Yeah.
Oh, 5-volt pins.
They expect 5 volts in. They output 5 volts.
Oh.
And it is a
Renesas RA4M1
yes.
Cortex M4 with an operating voltage of 5 volts.
Okay, it's an M4. Wow.
Yeah, so it's an M4. And
how many?
You thought I'd use it?
Okay.
Excuse me.
The thing that I've found as I've gotten the longer I play with robots, something like that. That's using essentially the Uno footprint. Is that correct, Pat?
Yeah, I'm using that board because of the Uno footprint, because of my motor driver that I've selected, and the space requirements on the board.
Yeah.
The
question I have is, does it still only have one serial port?
No. So it uses 2 serial ports. So there is the USB serial port, and then there is pins 0 and 1, which is a separate serial port.
Okay. That's a little bit better than the Uno for sure. But I'm using a Kibitzing, and it's got seven serial ports on it. And for some of my sensors, that's the easiest way to do it. You know what I mean? I just, especially like these those distant LiDARs, God, what were they? TF Minis, TF Mini Pluses. Those. The easiest way to talk to them is with the serial port. Now you can use I2C, but if you've got four, how a lot of times you array your distance sensors in front of you. If you're using those, having a lot of serial ports is cool. Plus they also have a couple of I2Cs, and they have CAN bus, which I have been playing with, and the more I mess with it, the more I'm convinced that that's something that you got to have. especially if you're starting to put multiple, if you go into modules where you're having a microcontroller over here and a microcontroller over here and a microcontroller up here, the CAN bus is definitely a way to talk to them. It's the most robust and simplest way to do with it, and it's not too hard. There's two versions. There's actually three versions that I know of, but the original simple one is pretty easy to work with. And there's good documentation all over the place for it. But you're the first person I know who's used the Minima. I think that's really cool. Where did you get it? I don't even think I've seen them for sale. They're sort of like,
I bought it out of Cool Electronics in the UK.
Oh, wow.
And the price was not bad when I looked at what it was supposed to be selling for in the US and Canada. The price was right on the mark. And shipping was approximately $4.
Wow.
From the UK. So I was really impressed with the shipping. It arrived in about a week.
Yeah, I wonder if that's because you're in Canada. Is it like a Commonwealth thingy or something?
Yeah, that was the first one I bought. I bought a second one since.
Yeah.
And I forget where I bought that one. Yeah, it might have been DigiKey or something.
Okay, because I haven't. I'm curious about it. It's a new board. It's really cool. I just haven't seen it, and so I haven't really dug into it. Sounds like it's got a lot of improvements. Well, the M4 is going to be blazingly fast. And then
they're running it at 48 megahertz and then 5-volt inputs and outputs, which was just fits well with the Arduino Uno footprint.
When you look at it, is it being? I would assume that they're level shifting on the board. Is that how they're handling that, or are the pins just
absolutely not? So if you go to, I don't know if I still have the site up.
I think that Renesas part just is native 5-volt.
Oh, okay. Cool. A little more silicon.
Yeah. So,
shipping might be cheaper because you're closer to the UK up there, Pat. I don't know. You had to ship it all the way down to Texas. It's a lot further. So.
Maybe. So that's what I got off the Arduino website, and there's no level shifters basically tied onto it.
I think Chris is right. It must be all built into the chip.
Yeah, it's a native 5-volt chip.
Mm-hmm. I wonder why they didn't make a Mega out of something similar like they did. It seems like that would be a good step forward too.
I'm glad they didn't, because at least it fits on my robot. And space constraint was one of the problems I had.
Yeah, that's good. Okay. Well, that's cool. And it solved all your issues. That's the best part.
Yeah, so it solved my issues with the timers, and I was thrilled with that I'm able to use it. So right now I pulled the board out because I didn't want to be flashing it and having it try to run motors when I'm not ready for it to go.
Mm-hmm.
And so I pulled the Uno out, but I will be putting it back in and swapping out my program to my other motor control program and see if I can start spinning some wheels.
Okay. I've got something that I'd like to talk. Are you finished, Pat?
I'm done. That's it for me.
Okay. This is let's see if I can get this. Have you guys seen this? This is a little small dual channel 2-motor H-bridge board. They sell pretty cheap. I want to say $12-$14 type thing. I think. I don't know. I have to look exactly. I ended up getting 2 of them somehow, and it's very simple to use. The little 8 PDIP, 8-pin PDIPs that it's got on it. They use MOS chips, MOSFETs. And so the very little drop in the H bridge and they can legitimately, without any question, handle four amps constantly. And there's some arguments on the webs, on the internet. Some of them put them at five amps. And they have a peak of 9 amps. So the problem is you can't cool them out fast enough. And I'm going to show you the back side of it. Can you guys see the traces, how they've made big wide traces? That's an attempt to pull the heat out of the back of the pins to the back plane. And that's one of the things that helps them get that current. And it's based on a, I can never remember it, TA 6586. So, and really, it's made specifically for small motors and stuff. I'll put it in here. Did I say 6586 or 8565?
Is that Toshiba? TA?
I don't know. 6586. 6586. Okay. So this was kind of interesting. It came across my mail, and so I'm really I may have a new favorite. You know, a new favorite Roborama sized motor controller. And the board is called a, because you can find it by here too, it's called ZK-5AD. So, you might take a look. I want to say they were pretty cheap. Since I'm recording, I can't really go look. Very simple to use. Basically,
Amazon.
$10. Yeah. That's for one. Look for two. Look for two. I think
yeah, that's 2 for 10, 1 for 5.
Okay, so I mean,
that's 5 for 17.
That's now you go in L286 prices. You know what I mean? It's a double. So well, I guess the other one is a double too. But so anyway, something new I came across I hadn't seen before. And then I've made the leap to this, to get this. And we'll see if it sits on my desk forever. This is a new single board computer I got. This is actually a Orange Pi 5. This one has 8 gigs in it. You can get 16 gig in this if you want to. It has a place in the back here, right here, where you can put an M2, drive there. So like the drive I have in this little thing I just put it, I can pull it out of this, slip it into here, and
SSD.
Yeah. So SSD. The one thing at this board, there are other boards, and this is like the cheapest version because I just wanted to put my toe in and see. They have what they call Orange Pi 5B, which has Wi-Fi. This one doesn't have Wi-Fi. You can add Wi-Fi to it. Okay, but the question you have to ask yourself, well, why not just use one of the USB ports and put a Wi-Fi adapter into it? So that's an option. And then they also have the Orange Pi 5 Plus, which has got lots of bells and whistles, but it's kind of expensive. I mean, This one, an 8 gig was $99 on Amazon. The probably 100, and the 4 gig was $80. So it's not that far from a Raspberry Pi 5. The big difference is this isn't Raspberry Pi, guys, so you don't have all that wonderful support that you have with the Raspberry Pi. But I think this can run Ubuntu natively on it. So I'll know more later. Right now, it's just literally came out of the little plastic bag. So I'll have to find out. So those are my two little show and tell items I wanted to share this week. So that's all I got.
Nobody's next?
No, I think Harold's next. Harold, what's going down? I don't think he's listening to us. Anyway.
I had one too many mutes on.
Yeah, I know how that is.
Yeah, not a whole lot. This thing that I'm doing right here, I modeled, well, this is something else, but I modeled this up on my stream, and what this little guy is part of the Pimeroni branding of tools, branding of boards, and this is called Pirate Radio, and it uses something called I2S. It's like I2C, but it's a streaming version of I2C. It's called I2S to stream audio and all those kinds of things to it. And on this board, you got 4 buttons and things, and it knows how to do something. It knows how to do, and it's got a decent DAC. So I've got that going as headphones out, and this is going to now provide music for my channel. I've got a Raspberry Pi 4 hanging in the very bottom of that thing with a big old heatsink on it. So I modeled all this stuff up around it, and I made a beastie of a model. I say a beastie. I just chunked some stuff in there till it fit, and this is what I came out with. Mm-hmm. There was a whole lot of planning. And what's going to happen is that sits in there like this. I have a faceplate that goes on it. Ooh, ah. And then that goes on here, and this whole thing holds down the Pi securely, so it doesn't go anywhere, and it fits. This fits on top of it, so it's not going to slide around and go somewhere. And so what I'm doing is using a software called Mopidy, Mopidy. It's Python based, and because it is Python based and it is open source, it's a server running there. And the plan is to install the MQTT extension to this, and then write some things for my Mr. Big Head, my robot, and Twitch streamers, so they can get up and change the genre of music and that kind of stuff, and can talk to it over MQTT, so they can make the volume go up and down, change the next song because they don't like it, whatever. We'll make some stuff on there and figure it out. Mm-hmm. That whole deal. And that's what I've been doing on my stream the last few times. What's going to happen Wednesday, tomorrow, is that we're going to crack open HugoBot again. I don't know if I've shown you HugoBot here in a little bit. Here, let me 1 second. It's right over here. My current, the guy I answer to, at my client, guy I answer to my client, I found out I had a 3D printer and I 3D printed, and he goes, "Does it work?" And I'm like, "Duh." And I knew I set this over here so where I get right at. Oh, I know where it went. I got project boxes of Doom in all kinds of places. And no. Ah, there it is. can't remember whether I showed this off with all the bits and pieces on it or not. So I'm going to show it off again. And what we're going to start doing Wednesday is because we have something coming up in May, don't we?
Yes, we do.
And so hopefully this will compete in lots of things in May. So if you want to see what's going on, you can look on over the top. And so this is it with all the pieces. And let me do this so I can do a roundabout here. If you want to pin me up so it's bigger, that's cool.
Yeah.
This is a Make Block Mega, which that's this control board down here. And this has got all the parts and pieces on it that I think I'm going to need. And what's going to start happening on Wednesday is we're going to start actually putting wires to this thing and putting it together. So this is a Teensy 4.1. It's got 3 different I2Cs, I2Cs on it. And what I found when I was playing with the controller here, which is an IMU, and the flow monitor, the optical flow sensor there, and the various things, they kind of wanted to be on different I2C channels, or at least that's what I was playing with, and it seems to be that way. And so I'm like, okay, cool, we can do that. And so we're going to start wiring that up and put it together. I've got I'm pretty sure no one's seen this. So modeled up this thing off the back. So this is like a 160 by 128 display. And this is an encoder. So I've got a wheel, I got a center push, and I got a 4-way thing. And we're going to wire that up so that we can control a menu here for setting things like calibrations and stuff, so I don't have to do programming at the event unless something really gone wrong. And since the Teensy has an SD card reader built into it, I figured we could do something to write out the config as we do, and use this thing over here to adjust the parameters. I don't know how many I'm going to need to adjust or how, but that's coming, right? And so we adjust it, save it to save between reboots. So because as I believe Ray's always told us, we go down and we set it down, and wherever we are, then we configure or because of floor types and all those other kind of things that you need to do, you need to calibrate it. And so once I have that calibrated, hopefully I'll be able to save it. So once I do it, I'll spend the 27 hours before our race. Isn't that how long we get in the room before then? Or maybe it's only a few hours. But anyway, so we can save it there. And then we got an IMU. This is a BN085 at the moment that we're plugging into it. And then the other thing I've got going on is if you're in the front, because I don't know if I showed you this. This is my front mount. And then I've got a Pimoroni garden connection, so I can put I2C onto that. But I might be just using the stemma connections that are on the 8x8 LiDAR that's on the front of this thing. And it goes out, if you can imagine, I'll go over the top. It's got about a 45-degree angle going each way for viewing things and seeing stuff, and it comes out in a grid. And then, of course, I think I showed off the mount the other day with the claws. The claw. And that's kind of how it does. And I've got it set up so I can. The idea is I can undo there's a couple of bolts here and a couple of nuts there, and this whole top should come off with only a couple of wires that go actually down into the chassis for doing stuff. So I was going to use the Mega that comes from Make Block as the motor controller, since it has motor controllers on them, and have it, like I'll tell it to go forward at an angle or doing whatever it is, and then have this thing be the smart thing, looking at the LiDAR and all the other sensors and tracking all that stuff. And that's what we're going to start plugging all this stuff in for reels Wednesday night and see how far we get. I imagine it's going to take a little bit to get it all wired up. Oh, and there's one other thing too I thought was cool. Here, let me open it up right fast. I saw these at Adafruit last time I was spending too much money. I know no one ever does any of that, right? Spend too much money on stuff. So this little guy, make sure I can see. I can see it. Okay, so this little fella right here.
Oh yeah.
This is a breakout board with the stemma QT for like dropping. I can drop in the sign one of my I2Cs and start pulling off I2C to go to my different boards.
Mm-hmm.
I got a couple of them. Going to see how they work. You know, maybe I can use a bunch of pre-built cables and plug them into all the stemma QT things, or to the individual. Like I've got individual. There's a stemma QT here, right? Mm-hmm. But sometimes I've got individual pins like on the backside of all this, or individual pins. And maybe I can mount this, I don't know, up here somewhere around, maybe make the connections a little bit more solid, because robots jiggling around tend to mess with these little home-built cables, which I will be building home-built cables. So anyway, that's what we're going to be playing with on tomorrow. We're starting to actually put it together and then start coding things up. I'm not sure where to start yet. Maybe I'll start with the encoder back here and make the screen work, just because, I like screens, things. Mm-hmm. And then eventually going to have to figure out how to communicate with the board, the Mega down here. But that's a USB connection. And luckily for everybody involved, that'd be me. There's supposed to be this Teensy supposed to be able to do a USB host, so I can plug it in there and do a serial off of it. Supposed to. I don't know if it does. We'll figure it out, right? Mm-hmm. That kind of thing. Cool. And so that's we're going to start playing with those things. And I like the mounting. I like the idea of being able to pull things apart if I need to fairly quickly and getting at it. And yeah, I modeled all this stuff up in Fusion and we printed it all out. And this is a PET-G, I2C PET-G on there. And it's pretty stiff. And I like the color.
Yeah. So
that's kind of what.
Yeah, since you brought it
fun.
up,
very cool.
Yeah,
we'll see if we can actually make it work. It's one thing to look cool, but Wildbot that goes and does something besides sitting still is probably way cooler looking robot. But that kind of thing.
What is your motor on the wheels?
The motor on the wheels. They're almost like those little yellow motors that we have, and there's no encoders on any of these things, which is kind of a detriment, but that's what came with the kit. And so I hope to use this optical flow sensor here to, not to say I don't need to worry about motor speed and all that kind of stuff, but to be able to track my position well enough so I know where I am and not depend on the rotations of the motors or not rotations of the motors to know where I am. This thing actually does work. It was kind of cool because when I was playing with it, I had one of my little test blocks. I could move it off and move it back to what I could visually see, and it was like dead on. When I was watching the X and Y coordinates move, and I had a trouble with the LiDAR here, and and it's still on there now. It didn't work as well as I wanted it to, but I figured that was just me not knowing something. And yeah, that was true. It was me not knowing something. There's a piece of tape on front of the LiDAR as it sits to the factory, so it get messed up.
What model is that optical flow sensor?
That optical flow sensor, it's a Pimoroni chip, and it is a PAA. Here, see if I can give you the number on it. Just right there.
There it is.
There it is.
5100J. Okay, got it.
Yeah, it's a short throw. They've got two of them. They got one for a long throw, like goes in the bottom of a drone, and this is the other one that's meant to be somewhere between 15 to 30 millimeters off the ground. And currently,
our Australian friend was playing with those, right?
Yeah. In fact, more than I was about to bring that up. The reason I have that board right there was more than likely is due to Murray conversing with the Pimoroni guys.
And so you're saying it works well?
It seemed to work well on the bench as I was testing it. But whether it's actually going to end up doing all I wanted to do, well, that's, as Mike Tyson says, everybody has a plan until they get punched in the face. So we'll see how that works. You know that, but anyway, that's my bench is a mess. My I don't want to say my life is a mess, but you know, with all this, my brother passed away in December 3rd, and dealing with all that and the holidays and all the other kind of stuff, trying to get other stuff done around the house. I've paid very little attention to my my workshop and my lab, but that needs to change if I'm going to have a hope of making this thing happen by sometime in May. Yeah. So, but I've tried to build into some of these things where I can shim them here a little bit here, a little bit there, slightly up or slightly down, at least in the front bits of this, so that so if I see something's in the way, like this LiDAR, it ought to be pretty good when the claws are retracted. I don't know if you see all that. When the claws are retracted that way, which is probably how it's going to be running around all over the place, it ought to be pretty decent with being able to see things out the front. And the way I designed this bit here I do a little closer up. I designed it so that you see how it's got a kind of curve to it, that I only put one in there. But if I need to go back and do a design and spread the curve out where I could put a couple more here and have them do some overlap. Let me make sure you see it. That should not be a big deal to then extend this curve out around there and then print it out again. So I can put a couple more of those things and get more of a almost a 180-degree field of view for that LiDAR. And then we'll get to see how well it works. That kind of stuff. Like this thing down here, this is made where I can shim underneath this a little bit. So if I want a slight up angle on my claw, you know, so when it grabs on it, tilts it, because I envision after watching everybody else that that as we're rolling over bits and pieces or even tape sometime, if I had a little front edge that I get a ramp up on and go over, it's probably helpful. Will be helpful. I don't know though for true, but we're gonna. It's meant to be that where I can loosen those bolts underneath there and put in a shim or something to put just a slight upward angle. So when this claw grabs, I'm telling you, I have lots of. No, I don't have any current cans here. But when it grabs one of those cans and grabs onto it, it's a good grab. It's a really good grab. So anyway, those are all the things. We've been off a month from HugoBot because we got him the way he is, and we've been working on other things like having our Arduino put out HDMI, which that ended up pretty cool. Using a big old 65-inch screen for your Arduino monitor, you know, that kind of stuff. That was kind of fun. Kind of stupid, but you know, whatever. And somebody wanted to see it, and I wanted to see it too, so we did it. And I've been working on the give me some better music. I'm tired of the iPad and iTunes. That could be just me being compressed or whatever, but the capabilities of that, if I can put a server on a Raspberry Pi, hook up the MQTT, and I've already got an MQTT broker in the house, that we can listen to it and we can talk to it and say, hey, change your channel, volume up, volume down, and that kind of thing. That's really cool. Can add to, adds to the channel, a little more interactivity. Somebody doesn't like my music and they want to change it. It costs them, I don't know, a few channel points to change it to something they like. All that kind of stuff. It's just it's interactivity and engagement is what it comes to.
Watch out! They'll be putting Yoko Ono on there for.
What? Well, I still get to control the music because I need to be very careful so that I don't get they're not going to strike me down, I don't think, but they're going to either blurt out music or just cut off the audio altogether, depending upon how the videos on demand go. And so I'm like, okay, well, I don't want to do that. There's plenty of DRM free music out there, and or music that I can sign up to or get a license to. It's not that not that big a deal, but it is a deal you need to be concerned about. And so, yeah, Yoko Ono's not going on there. Yeah, I'm pretty sure about that. I know I can make that happen. And they're not going to have access to actually put that music on there or not. So I've got a 512 gig SD card ready to dump a bunch of music on. I have over 300 gigs of music upstairs. That most of that's rips from CD-ROMs and other things that I've owned over the years. But I really can't use all of that. But I'm sure I can find me some other Stream Tunes is what I'm using now. You go to streamtunes.com. Here it is. I don't have a way to drop this in the chat, but it's just streamtunes.com. Oh, shut up. And mute it. And all of this music on here, which is over 50 hours of music, is DRM free if you register with them. So I'm registered, so I'm going to download every bit that they have and dump it on this thing. Some of it's actually really good. Most of it, yeah, it's like, wow. It's like some of this stuff. Was it chiptunes? No, what is it? That chiptune there, that's all Casio music, man. Somebody got up and did the 8-bit Casio thing and played it around on it and did tunes with it. Yeah, and all their stuff's on Spotify as well, so we can go download and listen to it. That kind of thing. Anyway, that's what I've been up to.
Cool. Been busy.
Yeah, sometimes not busy enough, but sometimes too busy, you know. And I got another story about a 6.5-foot pipe that came out of my front yard that I thought was bent and ended up being straight, but that's a whole nother story. It's been in my yard for 20 years, and I finally got tired of it and started digging it up. A neighbor came down and helped me, and I was surprised when it came out of the ground and not bent. So anyway, it's another story altogether, and you probably need picture references or something. But that's another. So I've been doing some stuff in the yard and that kind of stuff during the weekends.
Oh, that robot looks like it's going to be really neat, though.
Yeah, I hope it is. I hope that it works a quarter of cool that it looks, because then I might have something that can compete, because I think it looks really cool. The idea though is really to make this thing to do 6-can and probably 4-square.
Got it.
Thing. This thing is going to suck at the quick trip, because the Mecanum wheels, I don't think I'm going to get enough speed out of them to do.
Carl, I think his winning robot doesn't it use Mecanum? I think
we can try that too, because I've got that optical flow sensor down there, so I know if I'm zooming left or right. I should be able to tell where I'm scooting left or right and correct for that. And know the distance I went back and forth. So it could compete in all three of them, but right now I'm really gearing up towards 6-can, and we'll see about the other things as we go.
Okay.
Hey, Harold, I got an unrelated question. Last year, you were on your Twitch channel. You were exploring RAW 2 and trying to learn it. Where did you ever end up on that?
Well, where I ended up to drop back over here. That rover is powered all by ROS 2. It's on Galactic. It's not the newer Haskell or Hazlitt or whatever that is. And it does work, and it does. I can run around and control it. But what happened was, when I started trying to add sensors and GPS, I had a hard time doing that. So I stopped working on that and started playing with sensors and trying to figure out sensors and that kind of stuff, which kind of led to playing with the Hugo bot. One of my channel, one of the things that people can do is if they have so many channel points, they can redeem them, and we get to discuss a project they want me to do, and we'll start on that project and see where it goes. And in this case, this is how this got started. One of my subscribers said, "Oh, I got 50,000 channel points," which So you know how much this person's watched me. You get approximately 60 channel points every 20 minutes. He has over and he spent 50,000 and still had over 100,000 points. So he's watched me a whole lot. So when my subscribers have asked me to do something and I throw that out there, I'm like, yeah, that's fun. I mean, I might not have ever done this, but since they ask, I'm going to do it and we'll see where it goes. And so this thing kind of took on a life of its own with the Hugo bot, and part of my thought when I got this was to throw a Raspberry Pi on here and a ROS 2 and do some things, but because of all the other stuff was considered in the design, currently we're going to power this Teensy just straight up and do what the Teensy does, with a thought in my head that we could eventually put a Raspberry Pi on this instead and power with ROS 2 and do all those kind of things, because I really like ROS 2. I like it a lot. And if you go look at my one of my GitHub repos and find the Zemo XMO project, you'll see all the Docker containers I have, and I built my entire. I had, because I couldn't find an ARM version of Galactic to run on the Raspberry Pi. I had to go learn a bunch of Docker and Docker Compose to go build my own version of that, and then do my own compiles to make my own Galactic load on the thing and figure out how volumes work so everything's persisted. Because that's one of the things. The cool thing with Docker is that, hey, if things blow up, you just kill the container and start it back up, but then you lose everything you got. So if you want to hold on to that, you need to mount volumes that are local to a machine, or local to your Pi, or local to wherever it is. And it's like an NFS mount, or mounting a disk drive on the Linux side of the world. And so I got to learn about all that and figuring out how the host networking works and those kinds of things. I mean, when I've got that Zemo up and going on ROS 2 with the UDP, it's all on the same network. So I've got teleop coming off my laptop here that will control it and get data and do all those kinds of stuff, and talk to it with all the nodes and send in stuff. Yeah, I had it all kind of set up, but I started running into problems with figuring out how hardware worked. And because the ROS was complicated enough on top of it, I wanted to understand more how the hardware worked, and we kind of went down that road till we figured out more, and then come back to the ROS. And we just haven't come back to it. It's cool. I want to come back to it. I just hadn't.
Thanks very much, Harold. Sounds like you had a lot of fun, and happy you came out with a successful experience.
Yeah, I will tell you, I probably did everything wrong. And what I mean by that, I have about a bazillion nodes on here. And what I mean by I have a bazillion nodes, I have one node for servo. I have 12 servos on this thing. So that one servo node gets instantiated 12 times with different configurations, telling it whether it's a continuous or whether it's a rotation, and also giving it a name commensurate with its position on the robot. So the navigation, I say navigation, move forward. And then the navigation says, ooh, to move forward, I need to tell the left front and the left right, and I need to tell all these other continuous things to go forward if I want to turn at an angle. I've got the Ackerman steering so that the inside track turns a little sharper than the outside track, and we actually did math on that, so the math should be right. It should be so as the wheels turn, it can tell each one of those steering servos how to move. And not how to move, but hey, steering servo front left, I need you to be at 12 degrees. Cool, I got this. And then whatever the node is says, what does 12 degrees mean to me? And then you can tune each one of those configurations to make it, 12 degrees is really 13 to 14 degrees because this servo is a little wonky. That kind of stuff. It can do all those sorts of things. But when you're looking at my node graph, I got a bunch of them. It all feeds down to a motor controller eventually. And that servo controller then tells the actual motor controller on what channel and what give it the PWM so that channel will then do the servo in the right way. But that node knows how to do that. The navigation doesn't know how to do that. the teleop doesn't know how to do that. All it does is I push the joystick forward, and then all the other pieces and parts get around and listen to the teleop and go, oh, I know what to do with that. I can make that happen. I'm a navigation thing. I can do the stuff, all that kind of stuff.
Good. Thanks, man.
Okay. It's probably more than you wanted, Paul. I'm sorry about all that.
Maybe on a related topic to 6CAN, now that Pat has encouraged me to enter, I notice in the 2016 Club Robot GitHub repository, there's a set of STL files for a 3D printed claw. Anybody use it? Have any thoughts on it? Comments? Alternatives?
I use it fairly often on small robots. It's very simple. The jaws, it's made. It's a very classic type jaw. You can find it on things like that on Thingiverse all over the place. But one of the advantages of that particular design was that the jaws were configurable. Otherwise, the final jaw piece is screwed on. So you can unscrew it, put another one on, screw it back. It works with a single servo. It's relatively compact, but not, you saw on Harold's robot how big the claw stuck out in front.
Yes.
So this one is more compact than that. But if you really want to see one that's compact, you ought to take a look at one of the robots on Dave Anderson's site. He has it where the claws literally fold underneath the robot.
Yes, I've looked at his design extensively, and I'm quite impressed.
Yeah.
Ray, since you're holding your robot up there, just a bit of background. I examined the Robo Challenge videos for about 7 or 8 years because I was curious to know who entered and how well they did and what their robots looked like. And I have to admit that there are 2 people who, if they enter, they win, and you're one of them. What's your secret?
Oh, I don't know. It took several years and experimenting with different sensors and, kind of getting up to speed with, how to drive DC motors till to get the most speed out of them that you possibly can and all that kind of stuff. But
now your claw, what's special about it?
Well, this one it's a single servo design too. And there's actually, I don't know if you can see it well enough, but there's actually 2 3D printed gears here. So the servo just drives one side and then the gear drives the other side.
Okay.
And it's a little thin. Sometimes the can will kind of get stuck at an angle, not, straight up.
Okay.
And sometimes the duct tape on the can can be a little on the sticky side. And, it'd be better if you could get the can off whatever surface, it was on. And Scott, actually, his claws are quite a bit taller than mine are. And that kind of helps to keep, at least the can upright. Yes. But it's actually better to just raise it up just a little above the surface. So, because if it does drag or it does stick, it can slow your robot down or get it off course. So,
okay.
But,
yes, it's either you or Scott. Basically, Scott usually wins if he enters. So I was curious about his design.
Lately, anyway.
Well, the thing I noticed about both of your robots is the elegance of movement. There is no wasted motion. You look for a can, you find it, you go get it, you pick it up, and you never make a false move.
Well, yeah, if you win, you don't make a false move. But,
right. Anyway, thank you. Any other thoughts on can grabbers?
I was thinking of doing like I've never printed Ninja Flex before, but kind of a Ninja Flex finger so that when the thing closes, it actually pushes the can up a little bit. And I don't think anybody's experimented with it, but that's an easy way to get, you know, your claw to lift the can up just a little bit. It doesn't have to be much, but.
Do you have any sensors on your claw arms?
On this robot, I don't. On the other robot, this is going to replace my robot that I've had for a long time.
I noticed David Anderson uses sensors on the arms themselves to detect when he's actually got a can.
Yeah,
I use a switch actually.
Yeah, I do that too, Tom. I put a brake beam. Otherwise, I take one of those infrared sensors that you can buy for about $1. It has the two ends. I unsolder them and separate them and point them at each other. And that works.
Okay.
This is just I don't know, they used to call them micro switches, but it's got a tie wrap glued to it. And, you know, as I approach the can, it'll trip it. And that's what I use to close the, you know, the jaws together.
I was going to do exactly the same thing to detect the can. Yes.
Yep. Yeah. It's
that looks like Meccano. Your arms look like Meccano pieces.
Oh yeah. Yeah. I think this is the Big Lots cheap version of Meccano. It's not Meccano,
okay.
But a lot less expensive. The other thing that I used another switch for was to catch the goal. The goal is actually up at 1 foot. Say that again. You broke up.
He didn't say anything.
Oh, he didn't. Okay. Anyway, so yeah, it works really well. In can soccer, if the two robots would kind of get tied up, these would get kind of bent out of shape, but you can always bend them back, and they've done fairly well. So, but on this one, these are 3D printed encoders for the back of the motors. So it's just a disc with 30 slots in it, and it's not a quadrature encoder. It's just, you know, one channel encoder pretty much, but it's worked well. I've had several different sensors on it, different cameras. I'd actually scan it. This is a LiDAR on the top here, and I'd actually, you know, print out, you know, on an LCD kind of what it looked like and where I thought the center of the goal was. So I knew I had to, it's kind of like a point and shoot approach. You know, you'd find the center of the goal, rotate to it, and then, you know, go at it at a straight line, hoping to not hit either side of the goal and, you know, catch the center of the goal with the tie wrap. But it's worked pretty good.
Yeah, Tom, another robot that you might you're on the same talk with those people in
Vancouver.
Vancouver, right? There was a gentleman from Vancouver many years ago.
Marcus
came down, and he had a gorgeous robot, and his particular claws. They were I think they're called shark fin claws. They were made out of Ninja Flex, and what they do is they move parallel. They don't swing. They move parallel. And when they touch something, they just naturally, because of the way they're constructed, they have an inner side and an outer side that are joined together at different locations. I believe he used wire, and they would just wrap around the can. Very cute. I mean, very nice. He did a bang-up job.
I will ask him again about that. He mentioned on Sunday night in our meeting that he had participated, but he didn't tell me any details.
Yeah, he didn't actually do 6 scans, I don't believe. Maybe he did, but I remember him as doing big tabletop. That was the one I remember him in. So.
Very good.
Yeah.
On a related topic, I know LiDAR is not something that would be useful for 6CAN, but it has come up in our discussions with Vancouver and Ottawa, especially as people begin to think about more sophisticated implementations of robots and the use of ROS or ROS2, because those groups are also talking about it.
Yeah.
The subject of LiDARs came up. There are 4 people in Ottawa using LiDARs. There are several in Vancouver using them. And it sounds like there are at least 4 or 5 in this group who are using LiDARs. The question in my mind is, as I look to get my hands on a LiDAR to begin experimenting, which one should I get? So one of the Ottawa guys has volunteered to gather information on what everybody is using and what they think of it.
Well, if you go back 2 meetings, I think, we talked about LiDARs. I talked about the RP LiDAR's new C1. And somebody, I want to say it was Brad. I thought it was Brad.
It was me. I had a small one.
Brandon mentioned another one by, I think it was Trendwave.
The Japanese, Chinese place, Wave Share.
Wave Share, yeah. Okay.
That's where I bought it from. I think it's a clone of some other model.
Okay, so the RP LiDAR C1 is their newest entry, and it's inexpensive, but it's a true time of flight LiDAR, not a triangulation one. It's true. It's just time of flight. And it's only $60, I believe. And the one that Brandon said was very similar. I think his was 70 or 80, but it was very similar. And you know, you can if you look at the old RP LiDAR A series ones, those are more expensive, and their triangulation, and I don't think I don't see a place for them anymore. I think they're obsolete. But I might be wrong on that. I think Chris uses an S1, don't you, or something like that? You use a good one you got off of eBay.
It's an A2, so it was one step above the original A1. So it's faster than the A1. It can rotate faster, but it's still the triangulation.
Okay. I thought you had one of the newer ones. But anyway, so those are two that you might want to look at. Now, how does that apply to 6CANs? Well, if you look at soda can, it's 6 inches high. If you look at the walls of the arena, it's 8 inches high. So it is possible for you to run a LiDAR and get a map of the arena. Okay. And I believe Scott does that. I don't know if he does it actively now, but he has played with that idea. And so that's one way. You can use it. I mean, obviously you can use it to see where the cans are. That's also possible. But most people are using some sort of blob detector anyway, so they don't necessarily need that.
In one of the videos of one of the contests, Scott mentioned that he uses odometry for most of the short run navigation, and then he uses his LiDAR every time he picks up a can to check where he is to update his odometry.
That sounds about right. Yeah.
Since you brought it up though, blob detection. What are people using, and what would they recommend, and what do they hate?
There's so many choices now. I mean, that's I mean,
I prefer the Open MVH7.
yeah.
It's, there's tons of examples. You can fit different lenses on it. They're all, the 12 millimeter barrel lenses.
You can get one of those fancy shutters too, can't you, Ray?
Yeah, you can get a global shutter sensor. So this part screws off. There's, I don't know if you can see the two screws there.
I looked at their website. Someone in Vancouver suggested it as well.
Mm-hmm.
Yeah,
they're pricey. They're quite expensive.
What's the advantage of the global shutter?
No blur.
If you're moving quite a bit, the other one is like a kind of a scanned thing. So like for fast motion, you don't get the distortion that you do with, a scanning shutter. It's kind of like the images, almost like a snapshot. It's taken all at once, and there's very little, like if you're moving fast left to right, you won't get like tearing, or straight lines won't appear crooked because you're, it's still a scanned image for the one that's not a global shutter. Mm-hmm. And if you're moving as it's scanning, which, or moving fast when you're scanning, you'll get distortion. But the global shutters, you don't do that. But
yeah.
Do you find that you need to run blob detection continuously when you're seeking a can, or can you get away with one or two snapshots?
Yeah, pretty much. I use the centroid of the blob to steer the robot.
Okay, so you're basically doing real-time steering with blob detection as input.
Yeah. So my loop is 50 milliseconds, 20 times a second, and the camera is fast enough to give more than updates at a.
Yeah, part I was looking at was what kind of frame rate, frames per second, any type of blob detection can provide. Some discussion around, well, you've got to have incredibly fast, or no, you don't. You simply have to apply the data in a sophisticated way.
Yeah, kind of on a regular basis. It depends really on, like in the global shutter case, if it's, a fairly bright setting that you're looking at, you can go up to like 50 frames a second without any issue. So it's plenty fast enough.
Yes.
With, it's really easy. They have tools to help you like select the color ranges of whatever target you're trying to find, because it's not, typically not one color. If you're, depending on, how your lighting is, you can have bright spots on one side, shadows on the other. So, that just widens up the range of colors, that you're going to have to look for. What I do is I do several samples, and if I'm not finding, any blobs in that range, I'll go to the next range or next, color combinations and look for those. And it does that, on a frame by frame basis. So if it scans, doesn't see anything, keeps cycling through those till it finds one.
So you're finding that color variation in the contest itself is an issue?
Oh yeah, it is. It's the same thing with the Pixie cams. You'd or if you it's even worse if you go outside, and try to use the cameras and blob detection outside, because you can get full sun, you can get overcast skies, clouds come rolling in, and it
Or for everybody that didn't want Ray to win, you could just pay me to wear my bright orange shirt.
Yeah, there you go.
The one with the can painted on it.
Exactly.
So,
all right, good. Ray, thank you very much for sharing.
Sure.
Yeah. And then you asked others, and if you're on the low end cost, I think it's the Huffy lens and the Pixie cam. I think well, I don't know. Pixie Cam, I think it's about $70, if I remember right.
Yeah. And the Pixie 2, I don't think you can interchange lenses on it, can you?
Well, there's a Pixie 2 B or Pixie 2 Plus. Pixie 2 has two versions. There's one with a fixed lens, this little white thing that says Pixie on it. And then there's a next, because of that limitation, people didn't complain about it. They came out with a version that uses a 12 millimeter lens.
Yep.
And so I can't remember what they call it. It's something like 2 Plus or something like that.
Yep. Yeah, that is kind of nice. Like, that's, I don't even know what the
advantage of those, the Huffy lens and the Pixie are they're dead simple to use.
Yep.
Dead simple. Scott uses Pixie Cam.
Yeah, on his robot.
Yeah.
Yeah. So what's kind of nice about that? Like, this is a almost a fisheye, I think. I want to say that's 120-degree angle lens. That one more of a standard lens, so maybe maybe between 80 and 90 degrees of field of view. So it's kind of nice, just to swap out lenses and experiment, see what works best. The kind of the trade-off is with a wide angle lens, all the targets look much smaller because your field of view is so broad.
Yeah.
So, it has to be kind of a compromise between, you want it broad enough so that you can see, as much of the scene as possible, but not so broad that all your targets are now, 2 pixels big or something, because it'll be harder to find them in the.
Yeah. And I think the Pixie Cam, if I remember right, has a 70-degree field of view. And that seems to be a really good value. I guess the other contender that I can think of is the Maxi Bit, which is kind of like the poor man's. What is it again? The one we first started off with. Right. What is?
Yep. Yeah. Yeah. The Max Pi stuff.
Yeah. But the disadvantage of that is it's not quite it's not as slick as the other one, and it's probably the one with its interface looks very similar, and a lot of the examples will work on it. So there's for something as simple as blob detection, you probably wouldn't run into any real problems with it. But there are some things that get you in trouble.
Yep.
Okay, that again, all very useful stuff. I don't know anything about blob detection, and I don't know very much about video work. This is all going to be exploratory.
All of these.
I mean, you can do similar stuff with, OpenCV and a Raspberry Pi and a Raspberry Pi camera, but it's I don't know. There's just so many examples in the OpenMV IDE. Pretty much anything you think you want to do, he's got an example for. At least in my case, I haven't found. Well, I did find one thing. There's. It looked like at one point he was supporting cartoon mode, but then I don't know if that was someone's proprietary code, and they said, "No, I'm going to make this private and sell it or something." But
there are several interesting examples that make use of ESP32 cams running mini OpenCV and basically doing machine language training. Sort of the poor man's version of what Bob Cook did, if you saw his presentation. That looks very promising and looks very straightforward, but I will bet it's a much bigger chunk than I have time for.
Oh yeah, they're slow. They're not going to be fast cameras.
Maybe a few frames a second, but some argue much faster. But it depends upon the pixel size you're willing to use in compromise. So I don't know where that will go. So, and again, I've got so many other things I have to get working first. Okay, folks, thanks.
Okay. I have one more show and tell that I came across this week. This is a 3.5 inch screen. Very similar to the ones you've seen around for ages. But this is an HDMI screen. And I think it was about $12 on AliExpress. So it comes with a little, I don't know if this is very practical, but it comes with a little full-size HDMI to whatever's on a Pi 4. The reason why I say it, so the way it's meant to be used is you plug it in like this. So now that you've got the Pi 4 connector right there. The reason I'm not sure is because I don't know if there's enough cooling in the case to actually make it work. But that wasn't in my intent. But if you remember in Bob Cook's presentation, he had a little. I think his was an OLED that he had just stuck on the side that was providing him with certain updated information. No, actually, it was given a video. He was showing his cans position. I don't know if that was he might have had that in like debug mode, where he would like point it at something and see, so he could see locally what was going on. Well, this would be able to do the same function because this would work on a Pi. So anyway, kind of cool, cheap, not real expensive. And I have hooked it up to a Pi, and it's pretty nice.
So, Doug, what resolution does it end up running over HDMI?
It will be whatever your screen is.
So, like when a Pi boots up, what does it detect it as?
I think it's 1080.
Okay.
Yeah. And
the stuff would be pretty tiny, right?
Yeah. So yes, it is. Good point. but that's what it is.
I have just the thing.
Yeah. That's what he's gonna do.
It's not quite that.
He was illuminated.
It's not actually that tiny, but it is really. I mean, yeah. You would have to configure your screen to be what you want to see.
Right.
Yeah.
Okay. Thanks.
Yeah.
Just curious.
Yeah. So I was thinking of it probably that the easiest thing would be some sort of web page being served. You know. That was my thought. Some HTML web page. But anyway, I thought that was because a lot of them you see, I've seen them before where they plug into a Pi, but the problem with them is they hide the whole port is hidden, and you can't use it. And this one could do that if you set it up probably the easiest way. But if you didn't want to, you can like put it over here and have the Pi over here, and you don't need the ports. If you put it in the ports or you connect the right pins, you can also make it a touch screen. All right, it can provide a touch screen function, but I don't think I'll ever use that. All right. Anybody else got anything else they want to add?
I've got one quick show and tell.
Okay.
But been doing some bumper design for that Stingray robot. So I've got bumper mount. So it'll be, basically comes in two pieces. So I've got clear plastic that will slide in there so that the IRs can get through the glass. Otherwise, this is the bumper piece. It's on a spring-loaded mount. So these are the parts that go on the robot. So I printed that, and then I've been doing sensor plates. This is basically for a mock-up, but yeah, that's just the bumper. So the problem is the way that chassis that I showed works is it kind of gets in the way of the wheels, and so I have to kind of cover the wheels so that it don't hang up on, the gaps in the wheels and the chassis body. So kind of designed that, and that's the overall shape of it.
Okay, I'm having a little, Brad, I have a little, do you have a robot right there where you can kind of show us?
Let's see, I may have a picture. Let me bring it up.
Yeah, I'm kind of having a hard time visualizing it.
Yeah, I can do that. Give me 1 second. Pick out one that yeah, okay. I don't know how I can share the screen. I kind of
You should see a box with an arrow pointing up. I believe that's
okay. And let's see. Dang, it's hard to find a screen sometimes. Okay. Can you see that?
Yep.
Yeah.
Okay. So, so on here, you see how that shape in my camera? So basically, the bumper is covering this here, and it bends out to where it angles away and bends out from the wheels here. So it's covering the wheel so you won't run into obstacles. And then the motor mounts, there's one on the top and one on the bottom that are spring loaded. And this is the piece that basically, makes contact with the obstacle and, pushes in a micro switch. But that's the shape I'm going for. So these gaps are really just angle away from the chassis body and be to a point where when it's depressed from hitting an obstacle, it doesn't interfere with the wheels. So I don't know if that makes sense. So yeah. So that's kind of the shape. And so it's, it's got clear. So those are the two holes that are spring loaded. So they're on the top and bottom of the chassis. At some point, I'll just replace this with something that's clear on the top so that I can run a camera through it, but I'm not intending to do cameras at first anyway. So everything's either sonar or IR and bump switches at the start. So anyway, that's what I was working on this week, just designing and printing those. That actually is big enough that it almost doesn't work on my printer. Cool.
Can I present real quick?
Oh, am I still presenting?
No, can I? Oh, are you done?
Yeah, I'm done. Yeah.
Oh, okay.
That was it. Simple.
Okay. Okay. Can you see this?
I can see some code.
Okay, over on the right side, do you see the image of the cone?
Yeah.
Okay, so this is the OpenMV H7, and this is the code that I used for Robo Magellan. So these are the 1, 2, 3, 4, 5 different color ranges that I have for the thresholds. And this is, L, A, and B configuration. I mean, there are a zillion different codes, but they support RGB and LAB. Anyway, it's a little, it's darker certainly in the room than it would be outside. So these color ranges were selected for outside, so that's why the whole cone's not being highlighted. But this little X in the center here is the centroid of this blob. And, you know, if you look at it at different angles, it changes the centroid around. Let's see here, where is it? The top number here in the serial terminal is basically the centroid divided by 2, and I did that so I didn't have to use 9 bits to send it, because it's a 240 by 320 image, and I need 9 bits to send, you know, 320. So I just shifted it 1 bit, and then I shift it back after I receive it. 0 is the index, so I'm using this first threshold, and the large number here is the number of pixels in the blob, and you can threshold that, and you can calibrate that for size. So and the size tells you, you know, how far away you are from it. If you know how many pixels at so many feet away. So you can use that to determine, you know, how much further you have to go to get to the cone and that kind of stuff. So anyway, he provided code examples and I just modified it from that. And, you know, I send out just the X value of the centroid because I don't care about the Y, you know. And that's pretty much all you need to do is you know, to guide the robot to the cone is track that, you know, centroid value as it, you know, moves back and forth as the robot, you know, moves towards it. So
I admit, Ray, that is very, very slick. Thank you for the demonstration.
Anyway, it's not too complicated as far as, you know, what you have to do to get it to work. And the interface for the Pixie Cam is really kind of simple. You know, highlight a section that you want, you know, the color ranges that you want to track, and you can play with some of the camera adjustments, but you certainly don't have the flexibility that you have with it's not 100% OpenMV, or not. I said that wrong. It's not 100% OpenCV, but a lot of the statements that in the ID are similar, and some of them, like there's really in OpenCV, there isn't anything, you know, a function that you can just say, okay, I want to do blob detection, whereas on, you know, his IDE, he provides those. So it's so much easier to use that way. But anyway, oh, and then the other thing is, as far as power efficiency, this draws a whole hell of a lot less current than a Raspberry Pi 4 or whatever with a camera attached. I mean, this is under 100 milliamps, and I don't know, what's a Raspberry Pi 4, like 3.5 amps.
Well, that'd be truly loaded.
Yeah, it's nominal somewhere just under an amp, and when you hit it pretty hard, you might get it to 2 on a 4.
Yeah.
Yeah.
But it seems like anything you do with like OpenCV and a Raspberry Pi, it takes a lot of current. So, because you're doing, you know, a fair amount of processing and a lot of data, you know, the images and stuff. So,
yes, very slick.
Yep.
Cool stuff.
Anyway.
Anybody else? Guys, I'm going to tell you something. The video.
I think you're on mute, Doug.
The video. I'm got the echo. The video is going to be messed up but I think we will have a video. Signing off.
All right. Thank you. Good night.
Thank
See you guys
you.
next time.
All right.